Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of area of composite figures. This is standard 7.9C in the great state of Texas, and we are using item number 9 off the 2021 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got this strange looking shape. It's got two congruent squares. And so we've got a square there. Got this weird square here. And they were used to form this figure. They don't even name this figure. And so we've got this parallelogram as well. So remember, a parallelogram is any quadrilateral that's got two sets of parallel sides. So this top is parallel with the bottom, and this side is parallel with this side. And there's different types of parallelograms. So within that parallelogram classification, we've got rectangles, rhombuses, and squares. So we need to find the area, and you might be thinking, okay, well, I just need to find the area of each of these shapes. But what is the formula for the area of a parallelogram? Well, if you look on your mathematics chart, this is what you're actually going to find. In that area section, it's going to say rectangle. You might not have noticed that, or parallelogram. It's the exact same formula. Base times height. Now you might be thinking, holy cow, this parallelogram is a different shape than a rectangle. How in the world could it be the same? Well, take a look. Let's just visually take this chunk. They gave you the height right there, right? Let's take this. I'm going to shade this in right here. What if we were to put that, swap it right over here? I'm going to draw this in right here. Well, guess what I just did? I just made a rectangle. So a parallelogram has just got the two sides that are slanted. If you chop off one side, bring it over to the other side, you make a rectangle. So it's the exact same formula, base times height. Now, with a parallelogram, they're always going to give you this dotted line right here because the height can't be one of the sides like it can be with a rectangle. So let's figure out what each of these are. Remember, the area of a square equals the side length times itself. So that's 3 squared. So that just simply means 9 square meters. That's 9 square meters. This is 9 square meters. So we know we're going to have to add all of these up. 9, 9, so that's 18. The only one that's going to be a little bit of work is this parallelogram, because we know the area of a rectangle is base times height. The base is 6, but my height is 2.8, so I have a little bit of a decimal to worry about, but it's not going to be that difficult. So let's just figure out what this 2.8 times 6 is. So that is 48. That's 12, and add that 4 is going to be 16. So I've got 168, but remember, I've got one digit behind the decimal in my factor, so I've got one digit behind the decimal in my product, so 16.8, which makes about sense, because if I wanted to estimate this, right, this 2.8 rounds up to 3, so 6 times 3 is 18. So since I rounded my number up, that means my actual is going to be a little bit less, and 16.8 is less than 18. So just estimating still makes sense. So this is going to be 16.8 meters squared. And then all I need to do is add this up. The only tricky part is, let's make sure we get our decimals correct. I'll go ahead and make these 9.0. So I can add my 16.8, and it doesn't look like I'm kind of missing anything. So that's going to be my 8. And that is going to be 9 and 9 is going to be 18. That is 24. And that's 34.8 square meters, or meters squared. And so that gives me my answer of C.